Hello everyone, and welcome to today's webinar, Cabin Air Standard ISO 23875, Changing Lives, hosted by Mining Review Africa, Trisum Auto Electrical Engineering, and Cyclone International. My name is Laura Cornish. I am the Editor-in-Chief of Mining Review Africa and your moderator for today. ISO 23875 is a new international standard for a consistent approach to designing, testing, operating, and maintaining the air quality systems of operator enclosures. Adoption of the requirements and test methods outlined in the standard protects personnel inside operator enclosures. To share more details about the standard today, I'd like to welcome our panel. Johan Momberg, the new Business Development Manager for Risk Tech at Trisum. Jeff Moredock, the ISO Working Group Lead and Board Member for the International Society of Explosives Engineers. Liam Wilson, the former Global Chief Health Advisor for Rio Tinto and also a board member for the International Society of Explosives Engineers. Austin Brown, Vice President of Sales and Marketing for Cyclone, and Eddie Smith, the CEO of Trisum, who will be joining us at the end of the session for our Q&A. Before we dive into the session, I have a few housekeeping items to cover. First, today's webinar will be available on demand after the live session on miningreview.com and is accessible through the same link you're using now. We also have some great handouts for you to download giving more detail on the ISO standard, so please do remember to access these. Next, we'd love to hear from you during today's presentation. If you have a question for our guest speakers, please feel free to send it through to the Ask Staff a Question box on the right-hand side of your screen. We'll be answering questions during today's session. And if we don't get to your question, we will be sure to follow up with you afterwards. And lastly, we'd like to encourage you to share today's webinar with your social networks. So to officially kick off our session today, I would like to start by inviting you to participate in a poll. Our poll today is asking, how familiar are you with the ISO 2387 standard? Your options being, I'm not at all familiar with the standard, I'm somewhat familiar, perhaps only relatively familiar, or I'm very familiar with the standard. So your participation is really important to our panel and will give some great insight into understanding the market and your current stance on this new cabin ISO standard. It's also a great starting point in advising them on the way forward in terms of integration. So please do take our poll today. As a reminder, how familiar are you with the ISO 2387 standard? Not at all, somewhat familiar, relatively familiar, or very familiar. We'll leave the poll up on the screen for just a few more seconds so that you can participate. Fantastic. I'm now going to hand over to Johan, who's going to give us a short introduction into Trisum and the relationship with Cyclone. Johan, thank you very much.
Good day, everyone, and thank you for attending our webinar session today. Trisum Auto Electrical Engineering has been servicing the Southern African markets for the past 30 years. We are extremely familiar with complex air quality and air filtration needs. Partnering with Cyclone enables us to provide clean air solutions and for your most demanding and extreme working environments. Based on conversations with local mine leaders, operator fatigue and alertness are presenting issues and top of their mind for many mining leaders. The ISO 23875 provides a step-by-step playbook to address the operator fatigue that's caused by elevated CO2 levels and contaminants entering the cab. With that said, thank you, Laura, and over to you.
Super. Thank you very much to Johan. I'm now going to hand over to Jeff, who will kick us off with today's presentation. Thanks, Jeff.
Thank you, Laura. In 2018, I was asked by TC 82, Technical Committee 82 of the International Standards Organization to work with a group of subject matter experts on the development of a air quality standard for for cabs that are operating in mining environments. This effort was primarily to solve a couple of problems that the mining industry had. or has. One of them is operator air quality and health-related effects of poor air quality in operator enclosures. But it went beyond that. It went into maintenance, the opportunity to have a standardized maintenance program around a standardized way to provide air quality for an operator enclosure. And it also was addressing areas around things beyond dust, like the amount of CO2 that's inside of an operator enclosure, which has an impact on the ability of the operator to do his job correctly with good air quality. So there were some health-related, some safety-related issues. But one of the last things is just getting standardization around the way machines are built. Currently in the world today, many of the countries have different air quality requirements. And the consequence of that on the manufacturing side is that there's a lot of inconsistencies in the way machines are put together around the world, and very big differences between what goes on in one country versus what goes on in another country. So to improve trade, to make it easier for manufacturers to provide good air quality in operator enclosures, this standard idea was introduced with the hope that we could come together as an international community of miners with a way to protect operators and at the same time solve some of these other issues which were pressing. The consequence of this was a standard which addresses the life cycle of the machine from the time the machine is designed until the machine is retired. So in the design phases, we have specific things that we are interested in doing. Laura, if you could advance to the next slide. In the areas that we are concerned with, we are looking at specific things which need to be addressed, and these areas are how we are going to address dust concentrations inside of an operator enclosure on an ongoing basis, how we're going to reduce and maintain at an acceptable level the CO2 concentrations which are inside of the cab, which are caused as a consequence of the operator breathing. When in an enclosed cab, there's a limited amount of oxygen. That oxygen is consumed by the occupant, by the operator, and it's replaced by CO2. If fresh air is not coming into the cab continuously, then you see an increase in CO2 concentrations, which can be a problem for the operator, which will be a problem for the operator if it's not addressed. The other thing is, how do you know on an ongoing basis that the design is still working? So if you're at the factory and you put a design together, or if you're in an aftermarket situation where you've done an installation, one of the things we're concerned with is evaluating the cab, actually testing the cab's performance to ensure that the engineering control requirements, which are a part of the standard, have been correctly implemented and fully implemented, and that they actually work on the machine. And then that translates into an ongoing maintenance of the machine and an ongoing opportunity to continue to performance test the machine in these various areas. So when we talk about producing a machine with low CO2 concentrations, or I'll say acceptable CO2 concentrations in the cab, how do you know that it is continuously doing that? Well, the way that we know that it's continuously doing that is we are going to design it correctly. We're going to use the correct engineering controls. We're going to evaluate it through a performance test when that happens. And then we're going to put in the maintenance manual a maintenance routine which allows that to continue to happen along with ongoing performance tests. So when we put the performance testing together, this is not laboratory type testing. This is testing that's designed to be done in the field by maintenance people, by industrial hygienists, and on an ongoing basis. So as a part of a maintenance routine, it's not just replace the filter, it's replace the filter and on an annual basis, retest the cab to make sure that the systems are still working per their design. And this gives us an opportunity to ensure that on a continuing basis, the air quality in the cab is maintained. So as we talk about this, Laura, if you'll advance the slide one more, there's 5 areas as it relates to performance that are included in this standard. One of them we've already discussed, which is actually defining what the acceptable level of CO2 is in an operator enclosure. In the past, there has not been a performance requirement on CO2 levels inside of an operator enclosure. This standard gives a specific performance requirement, and it is defined in the standard itself. That is new. There are industrial hygiene thresholds. This identifies operating thresholds, which are much lower than the industrial hygiene thresholds, which are in place today but don't have as much of an impact because of how high they are on how often they're actually addressed inside of operator enclosures. The second thing is we're looking at filtration efficiency, particles that are present on the mine site. There are many types of particles, whatever you happen to be mining. It can be fibrous material, it can be particulate material, it can be coal dust, it can be particulate being generated from the engine, so diesel particulate matter, it can be anything. So what we're concerned with is that the filtration that is used in the system is sufficient enough to pull these fine particles out of the air. So there is a new standard which we are using. It is an ISO standard that addresses the manufacture and the classification of efficiency for filtration that's going to be used in operator enclosures. That is part of the standard as well. It means that when you buy a filter, that there's a specific classification that and specific labeling requirements that are a part of the standard to ensure that we have the correct filtration in the operator enclosure to be able to remove efficiently these particles which are dangerous for the health of the operator. So we have a concern for not only the intake air, the air that's coming in from the outside, that's coming into the cab to replace the air and give you the regenerated oxygen that you need to replace the CO2, but we're also talking about the recirculation airflows inside the cab. So that's a significant change. In the past, recirculation airflow filtration, there was not a requirement around that, either that it be there or that it have a specific classification of filtration associated with it. Laura, if you would please move on to the next slide for me. So as we talk about CO2 levels in the cab, we're specifically talking about whatever the ambient level of CO2, whatever the CO2 is naturally outside, plus 400 parts per million. And what this means is when the operator gets in the cab, the CO2 levels are going to rise because he's producing CO2 and it's in the enclosure with him. So there has to be sufficient fresh air intake in the cab to make sure that that CO2 level does not rise to a level higher than the ambient level, the outside level plus 400 ppm. So that's one of the performance requirements of the standard. Laura, next slide. Another one of the performance requirements that is that's in the standard has to do with, as we've already spoken to, recirculation efficiency. There is a performance requirement around this as well. The way that we know that we have the correct filters and that the cab is set up properly is that we run a very simple test where we introduce particulate into the cab and we turn on the recirculation system at a specific level of pressurization, and within 2 minutes the particulate levels in the cab have to fall below 25 micrograms per cubic meter. Now, this is an amazing accomplishment, both from an engineering perspective, but also this level of particulate contamination in the cab will maintain the health of the operator at a very high level. This is a really positive and constructive aspect of the standard. Next slide, please. So we're not only defining recirculation system efficiency, but we're also defining what the intake air efficiency is. They are actually both the same. So this new ISO standard, the ISO standard that's been adopted under 28375 or 23875 rather, has been around a while. We've adopted it because it's the most effective filtration manufacturing and testing and classification standard that is available, and it is now a part of ISO 23875. Next slide. Okay, so as it relates to cab pressurization, and cab pressurization has been around for a long time, and there's many people who know that cabs should be pressurized. We've defined what the minimum level of cab pressurization should be, and we've also defined what the maximum level of cab pressurization should be. And the thing that has changed in this standard, which is new, is that when the key is turned on and the electrical system is engaged, that the cab must attain a minimum of a 20 Pascal level of pressurization, which means that there's an active pressurization system on the cab such that when the key is turned on, it is actively protecting the operator by bringing in clean air and by dispensing and by not allowing other particles to come inside of the cab. Next slide, please. And lastly, how do we know that all this is going on? We know this is all working because there's a monitoring system in the cab, which is monitoring the CO2 levels in real time, monitoring the pressurization in real time in the cab as well, and giving alerts to the operator when things are not doing what they're supposed to be doing. So this is a program which seeks to identify the problems before they become long-standing problems. We want to get to them early. We want to make sure that the maintenance requirements that are listed in the maintenance manual are performed, and that ongoing performance testing is done so that the cab is continuously being looked at and being monitored to make sure that its performance is consistent. And if we can accomplish these things throughout the life cycle of a machine, we don't allow the machines to degrade to the point where they can't be fixed. They're continuously being scrutinized in the occupational health and safety management program in the site, and we have performance tests to validate that the cabs are working the way that they are designed to work. So this is all these things represent a huge leap forward as it relates to the protection of the operator and to making sure that the maintenance of the machine is consistent over the life of the machine. So this next slide, please. So these are the 5 areas that have been addressed. There are engineering controls that are called out in the standard. I would encourage everyone to get a copy of the standard and to read it. I think you'll find it interesting from an educational perspective. I think that you'll find it interesting in terms of the areas that are covered by the standard. There are new things referenced in here, including an annex which addresses the industrial hygiene and occupational health and safety aspects of the standard. It is designed to be educational. We do understand that it will there's a lot to the standard. It's not just what happens at the factory in the original design. The standard addresses what goes on with the retrofit side, what happens at the factory, what happens in the maintenance shop, what happens on the industrial hygiene, and on the administrative end of the cab throughout the life cycle of the machine. So we're very excited that we've had an opportunity to get an international consensus. This passed unanimously on the international balloting. It was formally adopted and published on February 22nd of this year. And we're very excited not only that it exists, but also that we're having an opportunity to present it to you today. Thank you, Laura.
Hi, Jeff. Thank you so much for such interesting information and for sharing that excitement with our audience. What a great start. So I would like to remind our audience, if they have a question specifically for Jeff, to put it in the Ask Staff a Question box on the right-hand side of your screen. Do note that the question is for Jeff if it pertains specifically to him. Otherwise, without further ado, I'm going to welcome Liam onto screen, and Liam's going to take us through the next portion of the presentations today. Liam, thanks so much.
Thanks very much, Laura. Today I'm going to be talking about the ISO standard from an industrial hygiene perspective. Next slide, please. So first of all, let's have a look at the benefits from the ISO standard. So when we look at who benefits, to be honest, as you can see from the slide there, there's not many that don't benefit from it. Those that do benefit include the machine operators, the mining companies, but also other industry, and we'll touch on that a little bit later, machine manufacturers, regulators, aftermarket retrofitters, machine owners, design engineers, reliability engineers, planners and maintainers, and of course, health and safety professionals. I suppose one point I'd really like to make is that although this is a mining standard, it provides the blueprint for adoption for non-mining industries working where there is a dust exposure risk present. Next slide, please. Again, just having a look at further the benefits of the ISO standard. One of the key aspects in the development of the standard was that there was significant involvement of industrial hygienists from around the world. And overall, compared to the traditional approach in developing ISO standards, this is a very different approach. Traditionally, it'd mainly be made up of different types of engineers. So being a part of the development of the standard was a pleasure, but also a fantastic approach that Jeff and the team from ISO took. One of the other key areas that occurred during the development of the standard was that hygienists from various companies from around the world provided actual data from operations which assisted in the development of the standard so that we can make sure it was practical and it could be achieved in the real world environment to protect operators. Other benefits include that we now have one international standard and one approach, and this results in a consistent application across the life cycle of the machine. And as Jeff mentioned, it covers both new equipment, but is also applicable to the retrofitting of existing equipment to manage that exposure risk. The other key piece is there's further information through the appendices, and one aspect of that is addressing the CO2 management and also the operational integration of the standard and application of it. I suppose the key takeaway from this slide is that it provides a practical document giving the user the what and the how to prevent exposures to the workers. And it takes an approach of a higher level of control in that control hierarchy around engineering to prevent exposure to the worker. Next slide, please. Continuing around benefits of the standard, and particularly around the worker health aspect. It provides a criteria which will protect worker health. For example, as has already been touched on, there are filter requirements, there's airflow, there's pressure, there's specific CO2 levels that are required. One contributor to alertness is CO2 levels. So the inclusion of the CO2 requirement and the real-time monitoring assists the operator alertness and the potential to reduce fatigue-related events. Look, just to be clear, I'm not saying that this is a solution to fatigue. There are many factors in causing fatigue, the main one being the lack of sleep. However, CO2 is a contributor to this, and this, having this continual monitoring of that and being able to alert the operator if the levels aren't within the required levels is a significant way of being able to manage that risk and the potential for an event. Look, the filtration requirements protect the worker from dust exposures and in preventing the long-term dust-related occupational diseases. So, for example, pneumoconiosis or silicosis related to silica dust exposure. This standard is a very real, practical way that companies can demonstrate their values and their care for workers in preventing exposure and managing risk. One additional note, not specific to the standard, but something that was developed as a result of that and with COVID, is that IC have written a report on operator enclosures and COVID-19. Next slide, please. What is the role for the occupational or the industrial hygienist in adopting, implementing and testing in regard to the standard? So in terms of our role as a hygiene professional, from an industry perspective, our role is to promote and inform the occupational hygiene and industrial community. And that role is to inform them on the standard itself, the benefits, and how it focuses on the prevention of exposures and worker protection. Examples of this can be the South African Institute of Occupational Hygiene, the International Council for Mining and Metals, the ICMMM, the Minerals Council of South Africa, and the Mining Industry Association of South Africa. So the more that we can work with those bodies and promote this standard and provide that education, a greater opportunity we have to protect worker health. From an organisational perspective or a business, Our role is to be the subject matter expert, to support and work with the operations and the maintenance teams. So to coach them, to provide some training on implementing and testing according to the standard. And overall, it's also to support the broader business to manage the dust exposure and to show the real benefits to the business that this standard can bring. Next slide, please. Next question, I suppose, is around, so why is this standard being adopted? So from a company or an organisational perspective, it aligns with the values of organisations, and also a number of organisations have internal standards, around airborne exposure and different levels that they would expect and allow within their organisation, and a lot of the time that may be more stringent than what regulators provide. Also, they may have a risk profile where we do have exposures or potential exposures to dust. So with that exposure risk, naturally the organisation wants everyone to go home healthy and safe, and this standard provides a way of doing that. The other piece for me is really around the standard can have very positive outcomes in terms of reputation, in terms of with regulators, and also from a cost benefit perspective. We all know that prevention is a lot better outcome, and from a financial perspective, prevention is a lot cheaper than either a lawsuit or fines from regulators. The other piece there is it's a higher level of control on the hierarchy. So as we've talked about, it's an engineering control, and it's really about preventing the exposure. And it can be a part also of different organisations where they have exposure reduction targets. This can help achieve that. Or at the front end with the health in design for new projects, it can be integrated to prevent these exposures up front. If you have a look down the bottom right-hand side, there's just a bow tie there around respirable dust and the preventative controls and the mitigating controls. The other piece with this standard is a value that it brings is we move health surveillance, which at times can traditionally be conducted to identify where we do have occupational diseases. This now moves it that once we implement this, we're actually moving that to ensuring that the controls are effective. So it allows that to be done. Another thing that is occurring is that there's a number of bodies and countries who have their own standards. They're just automatically adopting this standard into theirs. Lastly, just in terms of regulators, regulators are looking to or may adopt this standard as a requirement to manage the risk of exposure in their country. Next slide, please. So lastly, just around the integration of the standard into business, how is this occurring? So from an organisational perspective, many organisations are integrating the standard into their machinery purchasing specifications as a minimum requirement. So they're doing that for any new equipment that is being purchased, but they're also, when their equipment is going through a rebuild or retrofit, they're putting that into their specifications that this standard is the minimum requirement. The other piece from an industry perspective is that there are organisations and industry bodies that are integrating this into what they're doing. And they're working together on improved health and safety outcomes. And they're informing and promoting of the standard and integrating it into their design philosophies. An example is the earth moving equipment safety round table. Thank you, Laura.
Thank you so much, Liam. Great information, really valuable for our industry. So thank you so much for sharing that with us. I'm going to hand over to our last speaker, Austin. Before I do, I just want to note to our audience that Liam and Jeff are board members of the International Society of Environmental Enclosure Engineers. So I got that a little bit wrong in the beginning, but there it is corrected. Without further ado, Austin, I hand over to you. Thank you very much.
Thanks, Laura. So as Jeff and Liam have identified and walked through the specific performance requirements of ISO 23875, the new standard really outlines a practical and playbook, kind of play-by-play way to drive immediate benefit short-term through safety controls, as well as supporting long-term health outcomes through reduced exposure to harmful dust and particulate, which at the end of the day can save lives and improve the quality of lives of machine operators and industrial workers on mine sites around the world. In addition to the health benefits, businesses are focused on really three main things: making money, saving money, and reducing risk. We've really covered a lot of the risk reduction component so far, but that really boils down to reducing the long-term exposure to respirable particulate, and that reduces the likelihood of chronic lower lung disease. As we look at those other key focus areas, such as saving money, ISO 23875 helps mine sites, industrial hygienists, maintenance leads, health and safety executives, and operations leaders meet defined maintenance intervals for their fleet of heavy machinery, and overall reduce the cost of ownership for that machine, as well as for air filtration costs and systems. In addition to saving money, it allows companies to better retain employees and better recruit a workforce so that there is a productive, happy, and safe workforce at their site. And third, from a making money standpoint, if you're able to keep machines running at peak proficiency, reduce downtime, and keep crews running, you're able to hit operating and production numbers and metric outputs. So as you'll see on the next slide, we're really focused on how can you improve operator air quality through reducing occupational exposure and driving positive outcomes for the health and safety of workers, for the benefit of saving money on maintenance costs, and the ability to make more money through increased production, metrics, output, and overall organizational goals. And so over the past 13 or 14 months, air quality has been at the top of everyone's mind given the COVID-19 pandemic. COVID-19 has really created an increased awareness of what's in the air we breathe, because at the end of the day, the unseen threats on an industrial job site are really real. These small particles can cause big problems for an operator's health, big problems for the maintenance of machines, and big problems for crew productivity, and ultimately a company's bottom line. So now that you've heard all of the different performance and engineering requirements, you may be asking yourself, well, how do I do this practically at my job site? So Laura, if you turn to the next slide, you'll see that Cyclone has been specializing in how to do that for the last 30 years. For the last 30 years, we have developed clean air solutions for the most extreme debris-laden job sites around the world. With over 100 patents in the clean air space, including pre-cleaning, air filtration, and pressurization, we have developed a specialty of working with customers around the globe, like many of you, to address the most complex and demanding clean air challenges. As Liam mentioned, one of the biggest focus has to be on prevention versus reaction. And so through working with local experts such as Trisum Automotive, we're helping mine sites and other industrial job sites to deliver prevention solutions which positively impact outcomes, including both short-term controls, such as the alerts in the real-time cab monitor system that we'll go over a little bit later, but also long-term impacting exposure and supporting reduction targets and improving the long-term health outcomes through reduced exposure to respirable particulate. Over the next several slides, we're going to walk through step by step on how to meet the performance requirements that Jeff and Liam have outlined. If you look in the top right-hand corner, you'll see the 5 key performance requirements outlined and how they connect to each step. So the first item that we'll look at is fresh air system. So fresh air intake is critical to maintaining a safe operator environment. Sufficient fresh air entering the cab dilutes increased CO2, which allows an operator to stay mentally clear and aware of their surroundings. High levels of CO2 in the cab can result in operator fatigue and loss of operator alertness. Operator fatigue is one of the major contributors of near misses and preventable workplace incidents on job sites. And so by ensuring a clean, fresh, sufficient, sustained amount of air coming into the cab, it dilutes not only CO2 caused by the operator, but it also ensures that it provides clean air free of dust and particulate. So when evaluating a fresh air system, it's really important that you find a pre-cleaner, pressurizer, and filtration system that's able to do all 3 of these items. The pre-cleaner allows you to really clean out the largest dust and debris before it ever reaches the filter. The pressurizer ensures that the cab becomes a pressurized environment, keeping dust, respirable particulate, nanoparticles on the outside of the cab and prevents it from getting to the inside of the cab where it can be breathed in by the operator and or affect the technical controls or other air conditioning components. And then the third component of a fresh air system that you need to ensure is high efficiency filtration. We'll review it more thoroughly, but not all filters are created equal, and you need to ensure that you have a HEPA filter that's designed for human respiration. So as you'll see on the next slide, fresh air is one component to ensure that you get fresh air in the cabin, but it's just as important to ensure that the air inside the cabin stays clean throughout the course of the shift and overall throughout the entire workday. So some people might ask, if air comes in clean, well, how does respirable particulate get in? So as an operator opens a door throughout their shift, they bring in dust, debris, and things on their boots or on their clothing. You can actually see spikes in respirable particulate above the permissible level. A high quality recirculation system allows you to recover the air quality quickly and get it back below the permissible exposure limits when combined with a high efficiency filter and a proper fresh air system. The operator cab, when equipped with the right fresh air and recirculated system, is one of the most cost-effective ways to maintain PEL on industrial work sites around the globe. And at the end of the day, many OEM recirculation filters are not able to get you where you need to be from a decay rate, which is how long it takes you to recover from a spike in respirable particulate. And that's why you have to look at a high efficiency recirculation filter and recirculation system. So we've talked a lot about filters, both on the fresh air and the recirc. On the next slide, you'll actually see what are some of the specifications that you need to look for as you are purchasing filters for your job site. So one of the increased performance requirements of ISO 23875 is defining new efficiency levels. ISO 23875 measures filter efficiency by the most penetrating particle size, which at the end of the day is what is the particle size that can make its way through the filter and downstream. So the smaller the number, the better. One of the big misconceptions in the marketplace is that all HEPA filters are created equal. There's a big misconception that in order for something to be called a HEPA filter, that it has to be 99.9% effective at a 0.3 micron size. This is in fact not an industry standard at all. The new industry standard is focused on MPPS, and so the difference between the old and the new is the difference between boulders and BBs. So it's really important that you look for and understand the classification of the filter that's coming on site. The other thing to understand and really look for is from a control and prevention standpoint, new filters are able to capture smaller and smaller nanoparticles. The new cyclone filters released in the summer of 2020 from a HEPA perspective are able to arrest 99.995% of COVID-19 sized particles, as well as influenza particles. So it is a strong safety control and measure for not only 23875 compliance, but also health works. As you go to the next slide, the fourth item that we're looking at is real-time cab monitoring. And a cab monitor really helps you see the unseen threats on industrial job sites. The RESPA Advisor Plus is a pressure plus CO2 monitor that allows you to see unsafe levels of CO2 as they begin to rise in the operator cab, which helps the operator know in real time what type of air quality environment they're in. This will help prevent operator fatigue and loss of alertness. In addition, it alerts to loss of cab pressure, both of which have visual and audible alarms from a safety control standpoint. Cab pressure is really important because, as we covered, when cab pressure goes down, it can allow harmful particulate to enter the cab and thus increase the exposure to and likelihood of long-term health effects. The RESPA Advisor is one of the only monitors in the world that meets the ISO 23875 performance requirements due to the specific requirements around stringent sensor selection. So cab monitors are a really good short-term control that provides both the visual and audible alarm to meet the 23875 requirement. So we have a lot of really good questions coming in the chat box. Just as a reminder, if you have any specific questions, please drop them in there. Before we go to Q&A, did want to share 2 case studies. So if we'll advance 2 slides forward, because I wanted to share, these specific applications in real-world environments. The first case study is at an ore mine site that was facing a really serious fibrous substance, specifically asbestos, as well as silica exposure. We worked with the industrial hygienist, operations leadership, and fleet maintenance supervisors to equip one down-the-hole drill with the Cyclone RESPA fresh air and recirculation system. From there, we were able to compare it to a drill that had the standard OEM AC system. As you can see in the top graph, this is the drill that was the standard or the one with the OEM pressurizer. Throughout the entire working shift, the permissible level was above the red line. At no point did it actually go below what was permissible. However, in the second graph, you will see the drill equipped with the Cyclone solution, both from a fresh air and recirculation system, was able to maintain the permissible level below the target number throughout the entire shift, with the exception of a few spikes, which occurred as the operator opened their door. But you can see that the spike quickly returned to below the permissible level limit, thanks to the clean, fresh, sustained air coming into the cab, as well as the efficiency of the recirculation system. If you go to the next slide, you'll see a very similar experience, but this time we're going to go to a coal mine in South America. This was an extremely dusty, arid environment, and this large shovel was one of the heartbeats of the mining location, really moving a lot of overburden as well as production. The cab air quality system here, as you can see, there was a spike at the beginning as the operator went into the cab, but after that door was shut, the fresh air system combined with the recirculation system was able to deliver a very healthy, sustained, and consistent cab air quality experience throughout the rest of that shift. And so as we can see, the real-world application of the Cyclone products are allowed industrial hygienists, operation lead, and fleet maintenance supervisors to really drive towards a common goal of not only protecting operators, but also improving maintenance intervals and improving productivity. So now we're going to turn it over to Q&A.
Thank you so much, Austin. Before we do our Q&A, I'm going to ask our audience to launch, to do a second poll with us. So it is particularly interesting in light of our first poll question, which was asking if you are familiar with the standard. So 38% of the audience said that they are not at all familiar with the standard, and another 20% saying they are only somewhat familiar. So we've had a lot of insightful information provided by our panel about the standard, which has been informative and valuable. So our second poll is therefore asking, how likely are you to institute ISO 23875 on your work site? Not at all likely, somewhat likely, likely, or very likely. So I think a great question in light of the information that our panel has shared with us today. So please do participate in this particular poll. It'll give us great insight as to how you feel about the information that has been shared with you through our panel of experts. So again, we'll leave the poll up on the screen for a few more seconds just so that you can review your answers and do participate. Super, thanks very much. I would now like to invite the rest of the panel back onto screen. Eddie, for yourself as well, please do join me. Great. So we do have a lot of great questions that have come in from the audience. And Jeff, our first question is for you. It comes from Philip Owen. And Philip is asking, does the standard stipulate air quality requirements in the air intake?
The answer is, as far as the ambient air intake, no. We don't have any control over what is outside of the cab. The requirement is for the level of efficiency that the filter is going to remove the particle, the level of efficiency for the filter, which is stopping the particles from getting inside of the cab. You can have anything outside. We're only concerned about what's getting inside the cab, and the filter is what's going to prevent that from taking place. So the answer is no. There is not a requirement for the way you've asked the question.
Great, Jeff. Thank you very much. Liam, our next question from Francois Fontonda for you is asking, are there any specific scientific references available in respect to the relationship between operator fatigue and CO2 levels?
Yeah, thanks, Laura. Look, in terms of the specific between the relationship of fatigue and CO2 levels, I'm not aware of too many studies on that. There are a number of studies in terms of CO2 levels and related alertness and also cognitive work. So the Journal of Occupational and Environmental Hygiene does have some good studies there. The other, I suppose, resource to have a look at is things like the threshold limit values for CO2. So a number of those, or depending on your jurisdiction, your time-weighted averages or etc., they also discuss levels, and there's information on what levels result in the change of the cognitive value of people, and they can be very helpful in terms of determining that alertness and the type of levels that you're at a safe level versus where someone's alertness decreases and mental cognitive also increases.
Awesome, Liam. Thank you very much. Austin, the audience would like to know, does the standard only apply to new equipment, and is the standard only applicable to heavy machinery?
That's a great question. And, you know, as Liam had mentioned, we have several mine site and mining companies around the world that is adding 23875 to their new machine tenders, but it's not just new machines. It's actually all machines that are currently used on a mine site and or any industrial site. So it does include current fleet as well. And so we do work with customers to make sure that you have an opportunity to retrofit or install cyclone type solutions on existing machinery. And Laura, to your second question, you know, it's not just mine sites. This standard provides a very clear and practical playbook for all operator enclosures. And the interesting thing there is, you know, it's not operator cabins or operator cabs. It's all enclosures where an operator might be working. So this can be mobile heavy machinery, it can be a fixed plant, or it can even be a small office building on a mine site. Because at the end of the day, being exposed to dust is not limited to heavy machinery, and it's not limited to new heavy machinery. So our team, Jeff and his group, are really focused on how can we protect all operators on, you know, any sort of site through these safety controls and preventions.
Fantastic. Awesome. Thank you very much. Jeff, another question that's come from Francois. It's quite long, so just bear with me while I go through the whole question for you. Francois is saying, considering the capital and maintenance costs associated with CO2 detection instrumentation, what is the benefit of in-cab CO2 monitoring and pressure monitoring versus only pressure monitoring? Would you not expect CO2 levels to be near ambient if the pressure levels are maintained above specification?
Great question. Thank you for that. There's really two parts to this question. First of all, it has to do with the cost of monitoring CO2 in a cab. In the past, when CO2 test instruments, reference grade test instruments are being used, they are expensive. They are independent of other test and monitoring equipment that's being put in the cab. So you've got a cost associated with that. They're really not designed to be in a cab on a permanent basis. One of the great things about this new standard is that it has put pressure on the electronics industry, like Cyclone and their monitoring systems, to develop to integrate the CO2 into the pressure monitor, all of being done at a much lower cost than you would ever be able to provide if you were trying to do that with individual test instruments, and in a form factor that works inside of an operator enclosure. So you're getting an HMI that's outputting not only CO2 information, but all the information that's coming out of the monitoring system for the ISO, for the 23875 compliance. So that's part of it. I think you're going to be very happy with what you see the industry is doing to satisfy what the standard is asking for there. The second thing is in regards to CO2 levels and pressure. Why would you need both? And this is a really, really good question. It kind of strikes at the heart of a fundamental misunderstanding in cab pressurization as it relates to air exchange inside of the cab. And so let me illustrate it this way. If you were to blow into a balloon, you would get very high pressure in the balloon and you would get zero air exchange. So whatever the air is inside the balloon, it's not changing. So if you have a person in the balloon and they're breathing the oxygen and the only thing that's left is CO2, the volume of air is still there. It's just no longer primarily oxygen and CO2. It's just primarily CO2. The pressure stayed the same. So the issue is not, we are using CO2 as a way of determining how much fresh air is coming into the cab. So that the engineering control, rather than looking at it from the standpoint of trying to measure fresh air intake volume, we measure CO2 concentration, and there is a direct relationship between fresh air intake and CO2 concentration inside of the cab. When looking at the easiest way to make a determination as to whether or not there's sufficient fresh air, we determined that the lowest cost way to do it and the most effective way to do it was instead to measure CO2 concentrations in the cab. So that is the reason why we have CO2. A high pressure does not indicate air exchange in the cab. It just means the cab's not leaking. And if the cab's not leaking, the CO2 is not leaving. So high pressure is not necessarily a good thing if you don't have the air exchange going on inside the cab.
Thank you so much, Jeff.
Great question.
Liam, yeah. Excellent. Liam, a really good question for yourself. You know, you've covered a lot about the health and safety benefits of the standard. Are there any other benefits besides health and safety?
Oh, look, I think what Jeff touched on, but also what Austin touched on as well, in that there's massive benefits from life of the equipment. There's huge benefits in terms of saving companies money in terms of doing this well from equipment planning, scheduling, life of the equipment, the filters, etc. So there's that really significant benefit from a cost to the business. It's actually, as Austin discussed, it can actually save you money if you implement the standard, you schedule, and that's the life cycle of the whole piece of equipment. So I think there's a significant financial benefit in terms of utilising the standard as well.
Great, Liam, thank you. And really important to highlight that, I think. So great to have that addition. Austin, you know, we do already use high efficiency particulate air filters on some of our machines. Tell me, is that enough to actually meet this new ISO standard?
Yeah, Laura, you know, using HEPA filters is a really good first step, but at the end of the day, you have to make sure that HEPA filter is as advertised and actually meets the new standard efficiency rates. And so that's where I would, really challenge or invite the attendees to learn more about the HEPA filter that they're purchasing from the efficiency standpoint, but then also look at where is that filter going from a filter housing standpoint? So one of the big differences about the cyclone filter housing is that there is a self-cleaning application as well as its ejective. And so the way we handle air and land dust on the filter face, we're able to then, throughout the normal course of operating that machine, the dust actually falls off and is ejected out, increasing that filter life and reducing the total cost of ownership. So, great first step, but there's some additional things to look for to really maximize that safety control as well as the benefit of the systems.
Super, awesome, thank you very much. I'm going to try and squeeze in one or maybe two more questions. Jeff, a question from our audience asking, are there any documented negative health effects at pressures of more than 200 PA?
That is a great question as well, and I have been looking for such documentation. I will tell you that there's pretty good consensus around the world, at least on the subject matter expert side in operator enclosures, as to the effects of high pressure. My biggest concern about high pressure, this question dealing with the health effects, if you are running under high pressure, there's anecdotal information about people that experience problems with their ears, much like going up in an airplane, where they get headaches in the cab. There's a lot of different anecdotal information about that. As it relates to any specific studies, I'd like to put my hand on a study. If someone on the phone, on the webinar knows of one, please send it to us. I would love to add that to the collection of references that we have. I will tell you that high cab pressurization generally is a cause of low air exchange in the cab. From an engineering perspective, I'm not in favor of high cab pressurization because it generally results in not getting enough fresh air in the cab. We make the cab so tight and we get such great cab pressurization, but we fundamentally undermine the CO2 equation in the cab when we do that. And you're going to notice in the standard that it's much like other international standards as it relates to cab pressurization. We're looking at a minimum pressurization of 20 Pascal and a maximum pressurization of 200. Is there a magic number? No, it's just that if you look in the field at what's going on, the higher the cab pressurization, the greater the sealing of the cab, the less air exchange we're seeing in the cabs. It creates a safety risk. So high pressure is not by itself a good thing.
Jeff, thank you so much. Unfortunately, we are so close to ending the session. And before I do that, I would like to note to my panelists that the second poll results were really positive, and that 53% of our audience said that they were likely now to institute ISO 23875. So a great result, and clearly the information that you've shared has been really good. So on behalf of Trisom Auto Electrical Engineering, Cyclone International, and Mining Review Africa, I would like to thank my panel for taking the time today to share with the market this very important development in optimizing health and safety and operational efficiency through the new ISO cabin air quality standard. For those of you who would like to engage with a member of the panel further, please feel free to reach out and I will gladly facilitate further discussions. There were a lot more questions that we didn't get to, and we'll definitely facilitate getting those answered for you as well. Before we go, I'd like to remind you that a recording of today's webinar will be available on demand on miningreview.com. So please stay safe and keep well, and thank you so much for joining us today. Until next time, goodbye.